Hi everyone and welcome to our first webinar slash panel discussion today of our 3-month long Geospatial Weeks webinar series. It's International Women's Day today, so I'm really happy to kick off the series today with our wonderful panelists. And the title today of today's panel is From Scan to BIM, How Do We Improve Collaboration Between Different Systems and Industries? My name is Nicole. I'm your point cap moderator, and joining me today are Julia from Laser Scanning Europe, Gizem from Sila Geospatial, and Monica from GeoSlam. They will introduce themselves in just a few seconds, but before that, I want to point your attention to your GoToWebinar control panel. You should be able to see a tab that says chat. So if you have any questions, comments, whatever, please feel free to leave the question in the chat, and then we will try to answer them all at the end of the discussion. So yeah, without further ado, Julia, would you be so kind to be the first one to introduce yourself? Please introduce yourself and your job at Laser Scanning Europe, what you do.
Yes, thank you, Nicole. So my name is Julia Prică. I'm working for Laser Scanning for about 4 years and a half now. I work as a service and training engineer, meaning that I'm mostly doing demos for customers for different hardware and software solutions. And also I'm also working on the field, so doing the scanning job, and sometimes I also do the modeling part. So yeah, doing the 2D or 3D models.
Okay, thank you. So basically, Julia is our all-rounder today, who can talk about both sides of the scan to BIM coin. Gizem, would you go next?
Yeah, my name is Gizem. I'm working as technical support for Sila Instruments over 2 years. I am responsible for the support questions, the problems, errors, and the configuration of the instruments, making the sample tests and getting the sample data from the instruments, and also the providing the trainings for software side. I'm generally mostly working on the processing the data. So I'm dealing with the office softwares more than the field side, but I'm spending some time in the field to take care of the customer needs.
Thank you. And now, last but not least, Monica, please.
All right, my name is Monica Zabolita. I work as a senior solutions architect at GeoSlam, and I do sometimes demos, I do training, I support our sales channel. But the most interesting and important part of a job to me is working with the customers and understanding their needs, which I can then take back to our product and development teams, and then try and find and drill down to actual decision making based on the data. In some cases, that's the scan to BIM solution, or workflows. In some cases, it's something else. But yeah, that's pretty much a little bit about me, I guess.
Okay, great. So yeah, we invited you all today to talk about how can we actually improve the scan to BIM process. And when we say scan to BIM, it always sounds like, just 3 words and really easy. But at the end of the day, it's not really, because on one side, you have the surveyor on site who collects the data. Then sometimes then the surveyor has to somehow give the data to the BIM modeler, and they have to get a BIM model out of the data. And we want to talk a little bit about the collaboration between those two systems, professions, and industries. So my first question to you would be, as of right now, for example, maybe we will start with Gizem as someone who collects the data. What do you think, how confident are you right now with the whole scan to BIM process? What do you think, which aspects work smoothly already, and where do you see obstacles or room for improvement?
Well, I believe the most crucial part is just field applications. If you collect the data precisely or densely, you will be more comfortable creating the BIM, creating the modeling. Regarding the aspects, there are many people that have different responsibilities in the field. Same for the office. So everybody has a different idea, different background, and an experience. According to the environmental conditions, according to the area that you scan, it definitely changes the prospects, the view of side of that people, and everybody, like field crew, has the different may have different field applications, so they have different prospects for those areas. I believe the most difficult part is the communication, possibly, because we can't predict what the office people, what the modelers just expect from the data. That may require returning to the field and repeating the scanning process, or ending up completely mess, or you may spend more time than you expect. So probably the most challenging part is the communication and understanding standards of the modelers. And they just define the accuracy, they define the deliverables and all the collection.
Yeah, I see Monica and Julia are both nodding. Julia, you see it the same? Like, do you feel that this is sometimes a problem? And like, as someone who's working on both sides, sometimes, how do you deal with that communication problem?
Yeah, I also believe that communication is one of the main points when it comes to this all scan to BIM process, because yeah, on each side you are, so either as a modeler or is either on the in the scanning part, you need to know your scope of work. So yeah, things needs to be defined at first, like which LOD the customer needs, what's the scope of work, like which objects should be scanned, or which objects should be modeled. And starting with that, it comes like a long list of the choice of the equipment. We could scan with a terrestrial scanner, we could choose a mobile one like GeoSlam, for example, and then all of that has to be discussed in advance, so that we reach our desired product, or our desired result.
Mhm.
So, Monica, when you hear that, I think that's something the customers also come to you with. What is like? Do you, for example, go like, well, yeah, here's a list of things which you should communicate beforehand. Like, do you, for example, advise that to do that, or what
Yeah.
are the solutions you offer when they come
Yeah,
to that?
absolutely. Absolutely. So basically we always try to come back to the question, what level of detail maybe you want, or what is the decision you are going to be making from this data? Do you want a BIM model, or do you want to just see how the environment looks like, or you want a floor plan or something? All these questions coming back to us help us to find the best workflow from starting of the scan to delivering the model, right? So say, for example, if someone to us and says, no, I want, LOD 400, for example, right? Which is, a lot of work, and, it's a hard thing to do, right? So we can say, right, you can achieve, say, for example, LOD 300 with the GeoSlam system, and you can have additional pano camera mounted on it, to see, what the doors look like, or what is this particular structure like, I don't know, the cable or a socket. But again, all this comes back to what do they need? And once we start helping them to answer the question themselves, then we can start making that decision, because sometimes a customer can say, I want to see this, this, and that, but not necessarily it is true. Like it takes time to really get that answer out, and then based on that you can start talking about suggestions, I believe, or you can say what is your current workflow and start talking about that. So I guess in regards to the communication, it's not easy to ask hard questions or put the strategy for the questions, but once you try, I believe it's achievable. I think another challenge with scan to BIM is that there's a lot of work to do a good model. And there's lots of tools in the market, which is semi-automatic. But if you say, for example, we have a kitchen cupboard, which is all the way to the top, you won't see it from the scan data, right? So you kind of need to end up making some assumptions. So, and things like machine learning maybe would help in the future, but those assumptions won't disappear, I wouldn't think. So I think that's a big challenge for scan to BIM workflow.
Okay, so Gizem, you just mentioned that when you go out and then when you have the expectations what should be scanned and what not, then you go for different equipment, for example, because then you get an idea which equipment to use, which software to use, and all that. So could you, like, if I would come to you and I would ask you, Gizem, please do a scan for me, could you like tell us and the audience which would be the most important things you'd need to know from me in order to do your job right?
First, the area and the environment, even the temperature of the day and how bright or how cloudy that day, that will definitely affect the number of points that you collect or the quality of the scan points, as well as the panoramic images or any images that you collect over the scanners or the video. So the field of view, the distance that you set your scanner or using the handheld scanner, that will decide how many points you collect or what is the angle of the photos, what is the number of points. So area is the most important part. You can apply the same instrument on every occasion. That is the first point. If you are in a I don't know, treatment plant and covered with lots of pipelines, you cannot, you don't prefer to set up a terrestrial scanner in here, and you would prefer to use a handheld scanner like JOSLAM and just scanning in couple hours and finish the entire plant and the model. If you're outside, you need to consider some environmental parameters, such as if it's snowy or rainy, you will see some points that is reflected over the raindrops or snows. If you are covered with a glass area or the polished metal surfaces, you will face with the reflection. And if you are working in a very bright, very shiny day, you will face with radiance of the sun on your images. And if you are not very experienced, not enough experienced on the using the equipments, you will see different problems. Like if you walk with GeoSLAM very fast, you will face with relief displacement between the photos and some blur places. You will face the some places will be very dense, some places will be scanned very sparsely. So that will definitely affect the modeling and the cleaning the noises, how much time you spend on the noises while cleaning those noises. So these are some parameters, some of them. I mean, I'm sure field people probably has more ideas or more standards than I just expert in here.
Yeah, okay. So when you talk about cleaning noises, maybe Julia, you can take over that one. Like, can you explain what is meant with cleaning the noises and cleaning the point cloud for the modeler? So maybe the people on the other side can get a little bit, a little introduction into what actual data is sent to them, because that's always something, you know, people say scan to BIM and then the modeler just get the data, but before you actually hand over the data, there's a lot of work involved, right? Julia?
Yeah, so as Gizem already said, there are different surfaces that, do you still hear me?
Yeah, now I hear you again.
Is it all right?
Yeah.
Okay. As Gizem already said, there are different surfaces which can be scanned. So, for example, if there are mirrors, or if there are a lot of windows, there will be a lot of reflections. And then, of course, after the registration and all the scan processing, we will have to delete some parts of the point cloud. So this noise that is made by reflective surfaces, or just like the scanner sometimes makes like a mirroring image of the point cloud through the glass. All these parts of the point clouds will have to be erased, and there are also some tools, some automatic tools for eliminating noise out of point clouds. Those can be applied as well, and after cleaning and denoising the point cloud, this can be sent over to the modeler.
Can I ask a question?
Sure.
Julia, so what would be, the workflow? Say you get the scan data point cloud, and before you model, right? So you do some how do you clean the reflection noise? Is that just a manual cutting process, or you do something else with it? Is there any advice you could give us?
Yes, so as far as I know by now, this is just manual. So erasing the reflections or the mirrored point cloud, it's just a manual it's a manual workflow. So it's either I can either erase those parts of the point cloud in the 3D view, or I can go in the panoramas and, for example, see where windows are and erase those parts. Or, for example, where where are people moving, or this kind of shadowing that appears in the point cloud when there are moving objects in the scene.
Yeah, and that's that shadowing the moving objects, like I mean in I don't know, maybe Revit or something like that. Like that occludes your main structures, right? And if you try to model from that, it would be complicated, right? You wouldn't see what you want to model, or how would that look?
It's not only about occluding. So if it's occluding, then it's quite complicated, because it may be that some information is missing out of your interested area. But sometimes it's a bit confusing, because you don't really know what's in there, and it's a bit harder to find that in a CAD software. So when you already started to model, then in the panoramic views, or in the 3D view of the point cloud.
I think semi-automatic extractions has high importance at this point, like defining the geometries of the object and pulling out all the similar objects, and then classifying those objects and saving on the different layers. And toggle off, toggle on, just displaying the portion of the data will help you to clean up the rest of noises.
There are a couple of softwares that are doing semi-automatic recognition of different objects, for example, pipes, or you can even extract planes, or even walls and stuff, which are working quite all right. But most of the modelers, or most of the experienced modelers, are not using that on a regular basis. So just in some occasions, so to say.
And Julia, why are they not using it on a regular basis? Is it just not there, not quite there yet? So still not quite,
it's quite time consuming, and the modeling is not. I hope it's working. As I said, it's quite time consuming, And sometimes modeling it by hand, it's way faster for an experienced modeler because they can do already everything as built, so to say. Whereas when you use these semi-automatic tools, you will get a result, but that's not completely done. So you still have to do some work on it. For different objects, for example, in piping, this is quite useful because when there are a lot of pipes in the scene, then even for an experienced modeler, that's quite complicated to model everything. But for walls or different structure elements, sometimes, as far as I know, they will just prefer to do that manually.
Yeah, so would it be the same amount of time if you would try to model from scratch versus fixing up whatever the semi-automatic tool has done, or would not? What would be the trade-off here? Thank you.
Depending on the point cloud quality, it also, for this kind of semi-automatic extraction, most of them are working only with structured point clouds, meaning point clouds coming from terrestrial laser scanners. And it takes some time, depending on the quality of the point cloud and also on the size of it. It takes some time to automatically or semi-automatically recognize this. So most of the times is easier to just model them manually.
Okay.
Okay, great. I want to go back again a little to the conditions on site Isam talked about, because I think that's maybe an interesting fact for our audience to know. I mean, I guess many people know that weather conditions, of course, might affect your skin. But like, did you have days where there was a scan scheduled and you just had to go like, I'm sorry, I can't do it today? Like, when does that happen, and what are like how do you manage the expectations from the clients or for the modelers then? Like, how do you explain that, Gisem?
Well, that's kind of preference. Some of customers really enthusiastic and directly jump into the area and scan whatever they see. But sometimes some of customers, especially the construction customers, really careful about what they scan. Snowy probably the best example. Like if a construction area is covered lots of snow, it's going to be very difficult to display the actual point, where the actual point located, especially for the ground. And there will be lots of reflection from the snowy surfaces. So it's going to be really difficult to handle the point cloud when you come back to office. And you will see that the panoramic images won't work enough to help you to clean the noises over there. Probably the snow is an impact, but sometimes, yes, if the construction area is covered lots of objects, like the metal grates or shelves or the people working around it, or lots of movable objects around it, like the cars or the trucks, that might be very difficult because you will have like millions of points when you return to office and you have to clean half of them or at least a portion of them. That will take days. And instead of that, you can prefer some time that's not under construction. You can come back, make a clean scan, try to reduce the unmovable objects, and come back to office and take care of the processing the data. It might be easier for the modelers to display what scan point they have or what the image refers.
Okay, so what, like, I can see Julia Monica nod as well again. So what I'm taking from here, and I think that that's a good point to make also, it's just that when the surveyor comes in, what makes the work extremely or way easier for the modeler and the surveyor is that maybe clean up the scanning side before you send somebody over and try to, you know, just let everything there that you want to have on your scan and everything that will not be necessary for your scan, try to get that out first. I think that's good advice here, as far as I can see. Okay, yeah, so let's dive a little. I think we touched that topic a little bit already, but I think something which would be interesting as well, and maybe Julia or Monica, you can try to answer that one, because you're both have a little insight on the modeling side. What would you think what would be good for a surveyor to know about the modeling process? Like what should they keep in mind to make the life of a modeler easier? Want to
Julia,
go?
you want to take this one? And I can comment later.
Yeah, so for a surveyor, what they should keep in mind. So, for example, in my case, while I had to scan something with GeoSLAM, so I had to take care that we also took videos of the scanned areas. So I had to take care that I scan everywhere, or that I point the camera to each corner, so that the modeler will have enough information afterwards in order to see exactly what there is. Because sometimes, for example, this project was offices building, and there were a lot of drawers, or there were a lot of things sitting around, and sometimes they might be overlooked, or they might be seen as the wall, whereas it's just a drawer. Other things that the surveyor should take care about, so also like where when using a terrestrial laser scanner, the scanner shouldn't be positioned under a source of light, because then the panoramic view will be you won't be able to see anything in it. And maybe the modeler really wants to see something exactly in that scan position. And also to make as many positions as possible in order to scan, or to capture everything that might be of interest for the modeling, which again these kind of things should be talked in advance, so previous to the scanning.
If I may add a couple of things. First of all, in regards to a video and scanning with the GeoSLAM device, we can see that a lot of our customers who would do scan to BIM workflow, they would use ZEP panel, which is a screwable camera. It's a 360 view, which also allows for much more information within one picture, rather than trying to go through a little video, along the point cloud. That's one point. Yeah.
That project was longer time ago, when the TEPCAM was still not on the market.
All right, that's cool. That's cool. It's good. We learn and build up from there. So that's great feedback. Another point I wanted to mention is when working with mobile scanning, right? Like, it's great to pre-plan your survey. So when I just started with GeoSLAM, I would just turn on the scanner and go on walking, and I would miss things. But especially if it's a larger structure you're really trying to capture, and you've got one scan is about 30 minutes. So if you pre-plan your survey, you maybe have a little walk around before the scan starts. You can see where you can close loops and where the doors are, and how you can close, lots of different types of loops. And that, the loop not only allows the SLAM to have a good result, but also, if you have, I don't know, like if you're here and you walk around it, you go around all of the occlusions. So you have that extra detail, which is then good for modeling the structures. So, and again, if you do the loops, how Gizem said, you might have more density in one area versus another. But if you end up coming back from different orientation to the same area, you end up filling in some of the gaps. So that's also a good recommendation on mobile data capture.
So how would you, like, if we're talking about mobile right now, like what would you advise, like Gizem or Julia, maybe when working with terrestrial laser scanners? Like, would you sometimes just go around and like do a video, for example, to add, or what's your solution there?
So for example, so again, yeah, planning in advance, it's also can be also made when scanning with a terrestrial laser scanner. And yeah, especially if you're using spheres or targets, because yeah, you need to place them before starting to scan in order to have enough common references in more scans. And yeah, besides of that, yeah, what else? I don't know, Gizem, any other ideas?
The tripod, the height of the tripod, and the field of view is pretty important. What you see exactly from the scanner. So how are you gonna cover it? Even you say the full dome, like 360, it's going to be like if you see a giant columns or the walls or something, it's not going to scan the behind of it. So you need to decide where exactly you set up your scanner. So you decide the station. That's probably very important. And be careful about, you know, overlap is pretty important on the registration part, and same for the errors. But we need to pay more attention the overlap between the two stations. How dense, how close, and how far they see each other. So the next station will be very, you know, linked with the previous one, and you need to be careful that there will be enough overlap on the registration. So,
Yeah, I think this is a very important point also when scanning with a mobile laser scanner, because then, yeah, you really need to take care of the overlapping area, because otherwise you won't get those different areas together. So
You
yeah,
mean between scans? Or
yes. So yeah, when more than one scan is necessary for covering the whole area to be scanned.
yeah, absolutely.
we generally advise our customers to make a rough core scan, like whole entire area, so they have an idea when they return to office, the entire environment. And we also advise them to focus on specifically that the portion of, like, it might be the wall or the full indoor or just a portion of the wall. So two options that we offer to customers to try.
Yeah, maybe additional last point about the overlap, if I may. We can see, at least for GeoSLAM and mobile scanners, is that because it's based on SLAM, if you make an overlap in a very feature-rich area, that will allow for sure for the best. So it's a simple thing, but if you think about it, it allows for the most data to be crunched in a particular way for that it would work in the best way, right? So feature-rich area is also good for overlaps. At least
It helps you. It helps you automatic feature extraction, actually, when you define the unclassified or the ceilings or the other indoor features. When you apply the automatic extraction, it will definitely help you to having more dense points.
So yeah, I mean, if we're touching the subject anyway, could you explain a little bit more about the registration process? Because again, as someone who's not on site, really just on the receiving end of the data, I mean, I know from talking to some of our customers that registration is one of the most complicated parts of the scanning. That's a part that leaves a lot of room for errors, and it's also a part that can be sometimes really painful, especially if you have, for example, this kind of format and your customer needs it in another kind of format, where you have to use this software or that software to get different laser scanners together or whatever. So could you please elaborate a little bit on the whole registration process? Whoever wants to take the lead on that one.
Go, Julia.
Okay. So yeah, when scanning with a terrestrial laser scanner, we are usually, as I already mentioned, we're using spheres or targets. So we are doing a target-based registration in the end. Of course, there is also the option to not use this kind of references and do a cloud-to-cloud registration. The reason why we are almost all the time using spheres and targets is because the registration is more accurate, and it's also easier to eliminate errors when doing the registration. And yeah, the user, so yeah, the surveyor or whoever is doing the registration has a bit more control over the results. So yeah, as I said, when using a terrestrial laser scanner, the registration, for example, we are mainly using Faro, so we are going to do the registration in scene or in point cab. And afterwards, if we have to combine multiple point clouds coming from different sources, so for example, I had multiple times the case combining Faro or yeah, any other terrestrial laser scanner with GeoSlam, then yeah, we are using point cab for that, and there we are using same points. So we are just clicking on points to do the registration or to combine the point clouds together.
How long, like this sounds like a kind of manual process. How long will that take, like for, let's say, a smaller object with 100 scans in total, for example?
100 scans will take around 3 to 4 hours, I think, to do the registration. Yeah, and then depending on where the point cloud is going or what is the end result, yeah, it comes the eliminating the noise and cleaning the point cloud, and then either export the point cloud in a certain format, or just delivering the project itself if the customer has access to that platform, to that software.
Gizem, how do you approach this?
Well, we let customer decide actually, but we offer, of course, some registration tools. It might be the pairwise registration too, like pairing multiple points and try to stitch the different clouds onto each other. But at that point, the common parts, the contrast, and the sharp objects have high importance, so you can understand the corners or the flat surfaces. The common objects and the common area will definitely help you to make the registration better and a smooth process. And seeing the objects in a similar view is another point. Like if you look from a flat surface from different angles, like 45, 60, 75 angles, the scan points, the density of the scan will change. So the overlap change, and while making registration, the scan point that you paired will affect the stitching the clouds onto each other. Of course, some objects like targets are quite helpful at this point, especially spherical targets. So you don't have to worry about these things. Not always
So
that works.
So as far as I understood, you mainly use cloud-to-cloud registration, right?
Yes, it's probably taking more than, I can't imagine that we apply these things for 100 station setups or making the, full registration for all stations. Because every time we offer at least three pair of points, and we advise to pick the flat surfaces, common surfaces, like smooth surface or just picking the corner or of the object. So try to get the the best angle of the scan point. But it takes more than registering with the target for sure.
Okay.
Yeah.
What do you think about adjust to control feature? And have you ever tried it? Is there, or shall I explain it first what it is?
So I think it would be better to explain it. I know about it, but I still didn't get the chance to try it out.
Okay. So I'll speak a little bit about that. I hope that's okay. So not a long time ago, we have released this little thing which screws on the top of the handle like that. And when you walk around and you're scanning, you can put it down on a control point and wait for 10 seconds. And it's going to extract a point because the scanner notes it's not moving, right? So then we can collect at least 3 or 5, points like that. Minimum 3, but as you know, more. We can then take that into software. And with the new software, which you're currently building, if you have, say, for example, georeferenced points, you can, it will automatically put those together. So say if you have 3 scans, each of them have some overlapping ground control, you drop that in, it's going to find the constellation and will reference the point cloud. Say if you don't have the georeferencing, or you're not even bothered about that, if you have the same points in 2 scans, so it's like with an overlapping area, you can also use that for automatic registration. So I think there are, I would say, like the whole scan to BIM solution or workflow, there are things you can definitely automate, and there are a very large chunk of work which is it's very hard to automate. So those little steps in between, like referencing, cloud to cloud, stuff like that, there are ways to make it simpler and easier, and also take out the human error from it. While the end part of it, scan to the BIM model, the final deliverable, is very hard to automate, or at least that's my opinion, I would say.
I mean, Yulia, could you elaborate on this one? Because like I heard there are some, some automatic solutions, and you already said like, well, they're not quite there yet. But could you explain a little what can be done automatically already in the modeling part?
In the modeling part.
Yeah, Julia.
There are some software solutions already which allow you to automatically extract a couple of objects, as for example pipes or even structure elements as I-beams or stuff like that, which for sure or yeah, definitely it makes the modeler's job easier. These are actually, yeah, these, as I said, are quite time consuming because the software, they need to process all the point cloud in order to search for this kind of features. And part of that maybe also, there are also this kind of softwares that are doing the segmentation. So yeah, that you can also say or classify some parts of the point cloud, and then the modeler will see, okay, there should be a wall, and yeah, there should be a drawer, there should be, I don't know, a table or so. As far as I know, these kind of softwares, like based on the feature recognition, they are not that far away right now. But I think, yeah, it's going to be faster and faster from now on. And other than that, maybe, yeah, a couple of plugins that that allow the modeler to work a bit easier with the point cloud is, yeah, for example, the CAD plugins from PointCab, or also there are a couple of plugins from Faro, at least, yeah, the ones that I know about, that allow you to transfer the information from the point cloud to the CAD software, or directly in the CAD software allows you to easily to easily or easier working with the point cloud.
Okay, so if we're touching the subject already, is that something you would wish for in the future? Like from the modeling side, so just from that side, what do you wish like for the future? What kind of inventions or technology? What do you think which would make the work way easier or way the whole scan to BIM process from the modeler side? Which would be what would be something useful?
Yeah, so I think definitely the automatic extraction of objects would definitely be something very useful and would ease ease the job of a modeler. And also, like, because as we all know, modeling is quite time consuming, so you need also a lot of skills and skills from different areas of engineering or other stuff. And yeah, I think automated, or yeah, at least a part of that would definitely make an improvement in this area or in this regard.
And Gizem, what would you think from the surveyor side? What would be something you would say if this would exist tomorrow, it would make my job so much easier?
I don't know, but maybe it's already designed or invented. I'm not sure it's an invention, but having multiple lenses might be a good option for the surveyors, like detachable lenses that you can switch, depends on the place. That might be a nice idea. Like if you're uncomfortable with a certain lens that has a specific focal length, so you can switch one to another and getting more depth of the area, or making more zoom capabilities. That might help you to get precise, more accurate, and high resolution images. And I wish we had a kind of automatic extraction for the images directly, especially, enhancing this kind of application in the market. So possibly the detachable lenses is a good option for the people in future.
I see Monica's taking notes. Monica,
Yes.
what in your opinion what do you think? Maybe it's something you're already working on, but what in your opinion, what are you looking forward to? What kind of invention technology would you think would really fast up the whole process?
Well, that's good, and there are many ways to answer this question, right? So maybe I'll try to be brief. I guess, just as Julia said, automating the process on that larger area, where most of the time of the operator is being spent, which is BIM modeling, like automatic segmentation and so on. That would be really good, right? I would even call it a holy grail of the industry. If someone could create a BIM model out of the cloud, automatically. And of course, there are tools which do half of a job maybe. But if that would happen, that would really smooth out the whole workflow. It would be easy, and there wouldn't be no human error and so on. But looking at how machine learning is developing, and which is good, it will help out in the future. But there are still those assumptions. If we come back to the same problem with the cupboard, right, which is all the way up to the wall, and you're a human, you know that there's a wall behind it, but the wouldn't, right? So that's a really challenging problem to crack. But I guess with time, maybe we'll find another way around it, and working together, maybe we can, crack it at some point. Other than that, I don't know. I do like the pictures and combination of the, laser data along with the, RGB data, which, that's my favorite subject in the whole world. And there are lots of things you can do with that. And I would hope we could work more on that, and maybe we could achieve different types of better results. And finally, the denoising of the point clouds. I think that with things like machine learning, I think is much easier to solve. And just cleaning up the point cloud, this would be the intermediate stage great for the whole thing.
Okay, so we're all hoping for this to happen in the future. We're all looking forward to it. We know people are working it already. So we have 10 minutes left right now. Time flew by. I just checked the clock and I wasn't like, wow, okay. And we have a few questions already. So I'm gonna go ahead and read them out. I have like the first question was if you, Julia, if you could elaborate again about the position of the terrestrial laser scanner on the under light and why you shouldn't place it under direct light.
Yeah, so when placing the terrestrial laser scanner under the light, uh, it shouldn't be any issue for the laser scanner itself, but for the panoramic image. So when taking the images will be either very dark or very bright, so you wouldn't be able to see anything in the panoramic image. So that was the idea behind.
So just like if it's such a what would you suggest, like how much like how far away from the light should it be?
So just like, let's say the light is just ahead, yeah, above me, just put the scanner like this, somehow here, so it's not exactly below or yeah, under the light source. Yeah.
And then I have another question. Do you see a role for augmented reality in Scan to BIM? Is it just a toy or does it have real applications for BIM workflows?
I don't think it's just a toy, and I think it's quite useful for, especially at the customer's end, because most of the times, yeah, the customer, if we are just sending the Revit project, for example, they won't be able to see exactly what's in there. So yeah, virtual reality, or yeah, this VR or augmented reality allows the customer to see the model as in real life, and actually to walk through the whole model. And yeah, they can also make some comments, or yeah, they can just point at a, a specific object or a specific structure and say, okay, I want this changed, or I don't know, I'm not fine with that. And this can be made already. For example, let's say there's a model to be given to an architect or to the construction. So yeah, so that it will be built, and this kind of stuff can be already corrected before the construction starts. So yeah, I think it's quite a useful tool
Monica
in
Gizem,
Scan to BIM.
would you agree with that, or would you add something to that? Monica, we can't hear you, unfortunately. Maybe you've moved. Yeah, okay.
Sorry. Okay, absolutely. Yeah, I agree. I think especially down the customers, and just like Yuli is saying, with augmented reality, you can look at the wall, right, through your tablet and see pipes behind the wall. You can go back in history of how this building has been built. You know where to drill a hole, simply speaking, right? Maybe there you don't want to hit a pipe. I don't know. It's just, a couple of examples, I guess. But I believe it's like like this extra massive information sitting in I don't know, a tablet or glasses or whatever you're using, which is allowing you to again come back to the same main question: what is your decision? What is the action you're taking here, and what do you want to do with it, right? So I believe, yeah, it's a good tool. It will also get much better with time. Again, the positioning of that pipe, say behind the wall, it depends where you're standing and how you're holding the device. Whether it's glasses or a tablet you look through, and there's like these IMU issues and whatnot. I'm not gonna get into detail, but it's challenging. But I would say with time it will get better and it won't give you a headache as it can do now.
I think
Gizem?
scanning side has probably really use this kind of applications, because the planning of the scan and the project deadline can be rely on how much time you're gonna spend on scanning, and you can just decide where you're gonna make the station setup, how long you're gonna make the perform the scanning, or how many station that you can fit in a day. So you can plan everything using the augmented reality, just looking from that perspective and giving you more idea how long you can work on the project or what is the deadline averagely. So the planning probably uses these kind of applications. I believe. I mean,
That's a
from
great
our side.
idea, Gisam, I think. That's really a great idea. Like, I mean, if you have the device, right, you go around it, and it could potentially automatically calculate, you know, your circle and arrange how much overlap you would need, right? And just plump it out on the, you know, on the plan, and then you walk with the tablet and it says, okay, the scanner should go here.
Exactly. Like monitoring the status of the project. Monitoring is pretty
Mm.
important, like how far you are behind the project or how far below the front of project. So you
Yeah.
can
So
just give idea to customers.
using that for inspection. Yeah.
Okay. And like if we're talking about new technologies, more information, we do have to find a way to store this information and also share this information with someone. Like when you've done the scans and when you've done the bin modeling, maybe 10 years later, someone has to go into that exact model and then you know, understand what you did there. Do you guys think that this is also like something that still needs development, or are you comfortable that in 10 years this will be like with the work you've done right now, people will be just able to understand? Like, do you see that as a problem maybe, or what do you guys think?
Mhm. Well, if I may say a couple of things, I believe that the data management, and you know, historically, it's a challenge to crack, as we are all human, right? Do you remember where all your scans are from 2015? You know, do you have a system? So basically, in order to, and I know you guys in PointCap just developed PointCap Share, right, which is maybe a little bit of a help to your situation. But how do you conglomerate the whole information of each, say, surveyor who's doing it? And I'm not saying this needs to be some sort of a, you know, one database or anything, but how do you make that process easy and retrievable in a way that you don't end up going through a lot of folders? You know, say someone asks for 2015 data set of 1 in 200 scans you did, right? Or 500, 5,000, you know, what is the system would need to be applied? I think that is a very, very interesting situation to solve. And I really hope someone will do that really well with some out of the box thinking soon. So yeah, I guess that's my comment on that.
I believe, yeah, I believe making a comparison in different designs, like same area but in different dates, like give you more information how far you got the improvement on the industries and the systems. Probably the quality assurance, quality control will take place at that point. Just making comparison between two exact same place, but different units, different models, and different years. So the accuracy and the quality of the exact total area just gives you the idea, the difference. But I'm not sure what is going to happen if you have the old data belong to 10 years, 20 years before, and the new one. What is the effect in the BIM side? Are you going to use on the modeling or just skip entire point cloud and continue with the newest one? So that's a kind of decision of the customers, right? The decision of the modelers.
Yeah, so I think it depends what's, so for example, let's say I have a model of a building for that's 10 years old already. So it might be that nothing is in reality as it used to be 10 years ago. And yeah, we can just use that to compare what has changed or not. But
Mm.
yeah, I think another important part is the standardization of modeling, because for example, yeah, if everything was made purely geometrical 10 years ago, it might be that yeah, the modeler nowadays doesn't really understand what's in that model right now. So yeah, I think it's important that some sort of standards are being used also, so that in the future our current models could be understandable for
Mhm.
the future modelers. Yeah.
I think that's definitely something we all need to correct, because it would be so sad if you go out, do all this work, scan something, and then in 10 years it's useless because you have new technology, or maybe not useless, but you lose that very much information you were trying to get, or a part of it. So I think that's really something we have to establish. Last question, because we're already doing over time. Last question from the audience. Technological developments are you most excited to see in the future? I think that's in the context of augmented reality or artificial intelligence. What's your go-to? Maybe Gizem, you want to start?
Holography, probably my answer is holography. So right now we see everything in stereo or 2D images or 3D point cloud, and we visualize it. But the holography is just relies on 3 phases instead of 2 phases. So that would be great if we can have a kind of touchable point cloud, like for showing our customers touching or zooming out, and showing all the pipelines, or just doing the the region, showing just classify the regions, and showing the specific region, like entire pipelines of 20 floor building. So showing this kind of thing could be very nice and fancy. Probably holography in the future have a huge loud for the surveying market.
Interesting.
Next,
Yeah,
Julia.
that's cool. Yeah.
Julia,
Yeah,
maybe you
so
want to go next?
from my side, yes, I may or already said this automated workflows where yeah, more and more artificial intelligence will come in between. Also maybe on the scanning side, we will see some robotics part that will more or less yeah, replace the human side, and there will be just controlled by one operator, so we will see small robots walking around with the scanner and not people.
Yeah, the
And
scanner is
yeah,
gonna be inside, right? So.
yeah, kind of like that. Yeah, we will see. I think we are all looking forward to the new technologies.
So, Monica.
Well, from my side, I guess, as much you can look as utopic to this as you want, but if, looking into, digital twin ideas and all that stuff, it seems like potentially that if we prefabricate all the parts of a building or a structure which we put together, right? And we design what is this part is going to be, like a beam or a pipe or something, right? So once it sits all together in, and it might have sensors like in a material or something, like maybe you don't even need to even scan to BIM anymore, because you would have, a robot going there, putting the parts precisely where it's supposed to be. But again, this is a very utopic and so on. There is lots of, ways around it, I guess. But, I believe the most thing which is stopping us is sitting there and following the line along the point cloud. I think that takes a lot of time. And I just hope we can find, as you say, Julia, some ways around it. So maybe we can think from the box from the other perspective. What if we put, the sensors? You can even get some nowadays some materials like a paint which has some, sensors which move then the form different ways. Maybe something like that. I don't know.
Yeah,
Already are there, right? You've got the Boston Dynamics and this other one, which I forgot the name, but it's a big robot. You plump a scanner on it, it walks around. We did that with GeoSlam. And yeah, they just did the job for you. And the other one is like a human. You saw that video
Yeah.
where they're jumping and so on. So that's perfect. They can go do a job. Then we could just sit and have coffee.
well, yeah, I think that would be great for everybody. Still getting the same kind of money and everything, but just overlooking the robots and the segmentation processes and whatever, just making sure it works and giving it a human touch. I think that would be something to look forward in the future. So yeah, as I said, we're overboard time. Thank you very, very much for dedicating your time today. I wish you all a happy Women's Day today. I hope you're making something fun today, although nothing much is possible. It was really, really nice to have you guys here. I think we made a great kickoff for the whole webinar series. I want to also thank all the people who are still here, even though we went a little overboard with the time. And yeah, I hope we can all, or we will, like, I will definitely see Julia again in one of our future webinars and panels. And I hope maybe Gisem and Monica, you will tune in the next 3 months as well and watch one or two other panel discussions or webinars as well. Thank you very, very much. And yeah, goodbye.
Thank you.
Thank you for
Thank
having
you.
us.
Thank you.
Bye.
Bye.
Bye.